Thank you for being here today. Before I start, I would like to greet my panel. I am Dr. KAUSLAYAH and Dr. ABDUL HAKIM. Next, I would like to thanks to my supervisor, Dr. FREDDAWATI BINTI RASHIDDY WONG, and co-supervisor, Dr. YONG. I am AISAMUDDIN bin Muhammad SHAHRUM. I would like to share about my development of recycled PVC fly ash composite in my final year project 1. The summary behind of this project is the PVC waste is estimated to increase from 44.3 million tons to 59.72 million tons over 2025. The statistic of PVC waste that goes to landfill is 82%, incineration 50%, while for recycling is only 3%. The toxic gas released from incineration may threaten human health, which causing asthma, brain damage, and pulmonary cancer due to inhalation of poisonous gas. This study is an initiative to recycle the PVC waste into new engineering construction material in order to reduce the PVC waste end up in landfill and incineration. This recycled composite will combine the PVC waste as a matrix and fly ash as a filler. The goal of this study to get the optimum ratio of PVC and fly ash composite that can give the highest mechanical and thermal properties. The problem statement behind this project are PVC is a universal polymer that can be converted into wide application of product. The high production of PVC also increased the amount of PVC waste in our country. Therefore, the mechanical recycling is used to reduce the waste that goes to landfill and incineration. However, PVC has low strength and poor thermal stability, thus need special process of recycling and reuse. An alternative way to recycle PVC waste is to use filler as the core stabilizer in order to improve the mechanical and thermal properties. Every project needs to specify their objective in order to make the project run smoothly. So, in my project, the main aim of this project is to determine the optimum ratio of PVC fly ash composite. The specific objectives of this project are: first, to determine the optimum ratio of PVC fly ash composite in order to give highest tensile strength and compressive strength using tensile test and compressive test. Second, to determine the best ratio of PVC fly ash composite in order to give highest glass transition and degradation using DSC and TGA. And lastly, my objective is to analyze the morphological structure of the composite using scanning electron microscopy. The scope and limitation of this project are: the recycled PVC is collected from Zushi Recycling Center Klang, Selangor. Only electrical waste such as cable or wire is used in the composite. The fly ash is collected from TNB Power Station Klang, Selangor. The residue that produced during burning coal is bottom ash and fly ash. However, the fly ash is used as filler because of unique properties such as low particle size and low density. Next, I will share the literature view of this project. The worldwide production of PVC was recorded as 44.3 million tons metric in 2018. It is forecast that the global market size of PVC will grow to nearly 16 million tons metric in 2025 by Statista. At the end of service time of PVC, large amount of waste arise. The waste that goes to landfill and incineration could pose a serious burden to human and natural environment if the process is not properly controlled and monitored. Mechanical recycling is a simple method to recycle the waste and it is very popular in plastic industry. However, there are special processes need to be added to improve the properties of the waste for new application. This process consists of adding new components in the composite such as filler. In this review, we focus on the mechanical recycling process of the polymer to recycle the plastic waste. Next, I will share the research paper that relate to PVC and fly ash composite. The first paper it used PVC powder as matrix and fly ash as the filler. For additive, he adds stabilizer and lubricant in the composite. The process to make the composite is by mixing and compression. The next paper it used rigid PVC foam as metric and Cyanosphere fly ash as the filler. He add stabilizer and lubricant as additive in the composite. The process to make the composite is by mixing and extrusion. The next paper it used PVC electric waste as metric and type F fly ash as the filler. However, it does not add any additive in the composite. The process to make the composite is by mixing and compression. The similarity of the between this paper is it shows improvement in the mechanical properties with the addition of fly ash content. However, the improvement is only at a certain limit and it tends to decrease due to agglomeration. There are 6 steps to produce a specimen behind this project. First, we need to clean the recycled PVC to remove any contaminant parts. Next, we shred the recycled PVC into small particles. After that, we mix the fly ash with the recycled PVC. We continue with the extrusion process to produce a homogeneous composite. After that, we continue with the compression process to produce a plate with the 3 mm thickness. Lastly, we cut the plate follow the specimen test. There are 5 tests that we use behind this project. For mechanical, we use tensile test to determine the tensile strength. We use compressive test to determine the compressive strength. For the thermal, we use differential scanning calorimetry to determine the glass transition. Next, we use thermogravimetric analysis to determine the thermal degradation of the composite. For the morphological, we use scanning electron machine to study the morphological structure of the composite. Next, I will share the expected result for my project. The value that we get from mechanical test will insert follow the table. The addition of fly ash is expected to improve the mechanical properties of the composite. However, the decrement of mechanical properties can happen due to agglomeration. Therefore, the addition of coupling agent is needed to improve the addition between filler and matrix. The addition of coupling agent also can improve the strength, stiffness, and hardness of the composite. So, the highest mechanical properties of the composite can be achieved. Lastly, the thermal value from DSC and PGA will insert follow the table. The addition of fly ash is expected to improve the thermal properties of the composite. However, the lower addition between filler and matrix can decrease the glass transition and degradation temperature. This is because less energy is required to degrade the composite. Therefore, the addition of coupling agent is needed to improve the addition between filler and matrix. The addition of coupling agent also can improve energy required to degrade the composite. So, the highest thermal properties of the composite can be achieved. That's all from me. Thank you.